Welcome to KHAB 17, HSE Global Safety Leader Professional Training Academy. Introduction. Module 6, Permit to Work, LOTO and High-Risk Operations. In this session, we move from general safety awareness into one of the most critical areas of professional HSE practice, controlling high-risk work. This module is directly aligned with NEBOSH International General Certificate Principles, IOSH Managing Safely Expectations, and practical industry standards used in oil and gas, petrochemical plants, shutdown projects, construction sites, fabrication yards, and manufacturing facilities. By the end of this module, you should be able to explain the purpose and life cycle of a permit-to-work system. Apply Lockout Tagout or LOTO principles correctly. Identify confined space hazards and required controls. Inspect work-at-height systems and scaffolds. Support lifting operations safely. Participate confidently in permit-controlled environments. These are not classroom-only topics. These are the systems that prevent explosions, electrocutions, falls, toxic gas exposure, drop loads, and fatalities. Most serious industrial incidents happen when work control systems fail. A permit is issued without proper isolation. A lock is removed too early. Gas testing is skipped. A scaffold is altered without inspection. A suspended load enters an uncontrolled area. In NEBOSH terminology, these are failures of safe systems of work. Under ISO 45001, organizations are required to establish operational controls for hazardous activities. Permit systems and isolation procedures are examples of those controls. Remember this throughout the session. A permit does not make work safe. The controls attached to the permit make the work safe. Section 1. Advanced Permit to Work Systems. What is PTW? Learning objective. Understand the purpose, structure, life cycle, and control requirements of permit-to-work systems used for high-risk activities. Concept explanation. A permit-to-work system, commonly called PTW, is a formal documented process used to control hazardous work. It ensures hazards are identified, isolations are completed, precautions are verified, responsibilities are assigned, and communication is maintained. A PTW is not just paperwork. It is a risk control system. NEBOSH classifies PTW as part of a safe system of work. Typical activities requiring permits include hot work, confined space entry, electrical isolation, excavation, working at height, radiography, line breaking, critical lifting operations. In oil and gas facilities, permits are often color-coded and electronically tracked. Permit life cycle. Key points. 1. Permit request. The job is planned. Scope of work is defined. Risk assessment and method statement are reviewed. 2. Hazard identification. Hazards are identified. Flammable atmosphere. Stored energy. Pressure. Toxic chemicals. Simultaneous operations. 3. Isolation and controls. Required controls are implemented. Electrical isolation. Valve locking. Gas testing. Barricading. Firewatch. Rescue arrangements. 4. Permit authorization. Authorized person sign. Issuer. Receiver. Performing authority. 5. Toolbox talk. Workers are briefed before starting work. 6. Work execution. Work proceeds under stated conditions only. 7. Monitoring and revalidation. Conditions are monitored continuously. 8. Suspension or closure. Permit is suspended if conditions change. Example: gas detection alarm. Weather change. SIMOPS conflict. Shift change without handover. After work completion. Areas inspected. Tools removed. Isolations restored safely. Permit closed. SIMOPS. Simultaneous operations. SIMOPS means multiple activities occurring at the same time that may interact dangerously. Examples: welding near fuel transfer. Excavation near live cables. Crane lifting above scaffold crews. Painting near hot work. SIMOPS failures are major contributors to industrial accidents. Coordination meetings and permit reviews are essential. Shift handover. One common PTW failure is poor handover. If work extends beyond one shift, times the incoming supervisor must review conditions, times the permit may require revalidation, times isolations must be reconfirmed. Never assume conditions remain unchanged. Common PTW failures. Failure 1. Expired permit still in use. Prevention. Times strict validity monitoring. Times visible expiry times. Failure 2. Incomplete isolation. Prevention. Times physical verification. Times lock verification. Failure 3. Unauthorized work scope change. Prevention. Time stop work and reissue permit. Failure 4. Poor communication. Prevention. Times toolbox talks. Times permit display boards. Failure 5. SIMOPS conflict. Prevention. Times central permit coordination. Practical activity. PTW review exercise. Display a sample PTW. Ask learners to identify. Times missing signatures. Times expired dates. Times incomplete isolation points. Times missing gas test results. Times unclear job scope. Explain that this is exactly what HSE officers check during audits and site inspections. Quick quiz. Question 1. Can work continue after permit expiry? Answer. No. Work must stop unless the permit is formally extended or reissued. Question 2. Who owns the permit? Answer. The performing authority or permit receiver controls the permit during the job. Question 3. Why are permits displayed at the work site? Answer. To communicate hazards, controls, and authorization status clearly. Common failures and lessons learned. Many refinery explosions involved unauthorized hot work. A recurring issue is workers believing, "We've done this job many times." Familiarity creates complacency. A permit system exists because hazardous work must never rely on memory or assumptions. On-site application. In shutdowns and maintenance turnarounds, junior HSE officers often times verify permits, times monitor work conditions, times participate in SIMOPS meetings, times inspect isolations, times and ensure permit compliance. This is one of the first responsibilities given to entry-level HSE personnel in oil and gas environments. Section 2, Lockout Tagout, LOTO. LOTO Fundamentals. Learning Objective. Understand how hazardous energy is isolated, controlled, verified, and restored safely. Concept explanation. LOTO stands for Lockout Tagout. It is a system used to isolate hazardous energy before maintenance or servicing. The purpose is simple. Prevent unexpected startup or energy release. Energy sources include times electrical, times mechanical, times hydraulic, times pneumatic, times thermal, times chemical, times gravity, times stored pressure. Many fatalities occur because workers assume equipment is dead when it is not. Energy isolation hierarchy. Step 1. Shut down equipment. Follow normal shutdown procedures. Step 2. Isolate energy source. Open disconnects. Close valves. Remove fuses. Step 3. Apply locks and tags. Each worker applies a personal lock. Tags identify. Times who applied it. Times department. Times date. Times reason. Step 4. Release stored energy. This is critical. Stored energy may remain in times capacitors, times hydraulic systems, times elevated loads, times compressed springs, times pressure lines. Step 5. Verify zero energy. Test before work. This is non-negotiable. Verification of zero energy. Testing means times attempting startup, times using voltage testers, times pressure checks, times confirming equipment cannot move. Many serious injuries happen because workers skipped verification. Personal locks. Each worker must control their own lock. Never. Times share keys. Times remove another person's lock. Times bypass isolation. Group LOTO. During shutdowns, many workers may work on one system. A group lockbox is used. The primary isolation key is locked inside the box. Each worker places their personal lock on the group box. The equipment cannot restart until every worker removes their lock. Practical activity. Mock LOTO. Demonstrate isolation on times a pump motor, times conveyor, times generator panel. Show times shutdown, times isolation, times lock placement, Times tag placement. Times test before touch verification. Ask learners, what stored energy hazards remain? Quick quiz. Question 1. Why must equipment be tested before work? Answer. To verify that all energy sources are isolated and that the equipment cannot restart. Question 2. Who removes locks? Answer. Only the worker who applied the lock, except under formal emergency removal procedures. Question 3. What is stored energy? Answer. Residual energy remaining after shutdown, such as pressure, electricity, heat, gravity, or spring tension. Common failures and lessons learned. A common fatal incident occurs when times one worker isolates equipment, times another worker assumes isolation is complete, times stored energy releases unexpectedly. LOTO failures usually involve times poor communication, times skipped verification, times unauthorized lock removal, on-site application, during maintenance shutdowns, junior HSE staff frequently, times inspect lock stations, times verify isolations, times monitor electrical permits, times check lockbox procedures, times and audit isolation integrity. LOTO competence is highly valued in oil and gas maintenance operations. Section 3. Confined space entry. Confined space hazards. Learning objective. Understand confined space hazards, atmospheric testing requirements, and emergency controls. Concept explanation. A confined space is an enclosed or partially enclosed area with times limited entry or exit, times poor natural ventilation, times potential for a hazardous atmosphere. Examples: times tanks, times vessels, times silos, times sewers, times pits, times manholes, times pipelines. Confined spaces kill quickly. Most fatalities occur due to times oxygen deficiency, times toxic gas, times flammable atmosphere, times poor rescue planning. Atmospheric hazards. Oxygen deficiency. Normal oxygen level 20.9%. Low oxygen causes times dizziness, times unconsciousness, times death. Flammable atmosphere measured using LEL. Lower explosive limit. Toxic atmosphere. Common gases. Times H2S. Times CO. Times solvent vapors. Gas testing sequence. Gas testing sequence. Always test in this order. 1. Oxygen. Without oxygen, gas readings become unreliable. 2. Flammable gas. LEL. Determine explosion risk. 3. Toxic gases, such as times H2S, times CO. Gas detectors must be times calibrated, times bump tested, times appropriate for hazards. Ventilation. Mechanical ventilation may be required. Ventilation. Times removes contaminants. Times improves oxygen levels. Times reduces flammable concentrations. Standby attendant. The standby man remains outside the space. Responsibilities. Times maintain communication. Times monitor entry. Times activate rescue. Times prevent unauthorized entry. The standby attendant must never abandon their position. Rescue planning. Never enter confined space without rescue capability. Many multiple fatality incidents occur when co-workers attempt a rescue without protection. Rescue arrangements may include times tripod systems, times breathing apparatus, times rescue teams, times retrieval lines. Practical activity. Entry inspection. Present a confined space setup. Ask learners to identify missing controls. Times no gas test. Times no attendant. Times poor ventilation. Times missing rescue equipment. Times expired permit. Quick quiz. Question 1. What is a normal oxygen level? Answer: 20.9%. Question 2. Why must a rescue be planned before entry? Answer: because emergencies develop rapidly and unplanned rescue often causes additional fatalities. Question 3. What is the role of the standby attendant? Answer: monitor entrance, maintain communication, and initiate emergency response. Common failures and lessons learned. One major refinery incident involved workers entering a vessel without atmospheric testing. Oxygen deficiency caused collapse within seconds. Additional workers entered attempting a rescue and also died. Confined space incidents often become multiple fatality events. On-site application. Confined space work is common during times shutdown cleaning, times tank inspection, times vessel maintenance, times catalyst replacement, junior HSE personnel often, times verify gas tests, times monitor permits, times inspect rescue setups, times maintain entry logs. Section 4. Working at height and scaffold safety. E. Learning objective. Understand fall prevention systems, scaffold safety, and dropped object controls. Concept explanation. Working at height means any activity where fall could cause injury. Falls remain one of the leading causes of workplace fatalities globally. Fall prevention versus fall arrest. Fall prevention prevents the worker from reaching a fall hazard. Examples: times guardrails, times fixed platforms, times barriers. Preferred control method. Fall arrest stops a worker after fall occurs. Examples: times harness, times lanyard, times inertia reel. Fall arrest minimizes injury but does not eliminate fall risk. Scaffold safety. Scaffolds must times be erected by competent persons, times inspected regularly, times tagged clearly. Scaffold tagging. RAG tagging system. Green tag, safer use. Yellow tag, restricted use. Red tag, unsafe, do not use. Workers must never use untagged scaffolds. Harness inspection. Pre-use checks include times cuts, times frayed stitching, times UV damage, times damaged buckles, times distorted hooks. Defective harnesses must be removed from service immediately. Anchor points. Anchor points must times support required loads, times be approved, time prevent swing fall hazards. Never anchor to weak structures. Dropped object prevention. Dropped objects kill workers below. Controls include times tool lanyards, times exclusion zones, times tow boards, times secured materials, ladder safety, inspect fall, times cracks, times bent rails, times missing feet, times damaged rungs. Maintain, times 3 points of contact, times correct angle, times stable footing. Practical activity. Height safety inspection. Conduct, times scaffold inspection, times ladder inspection, times harness inspection. Ask learners to identify times missing tow boards, times defective webbing, times poor anchorage, times missing tags. Quick quiz. Question 1. What does a red scaffold tag mean? Answer: unsafe for use. Question 2. Why inspect harness webbing? Answer: damage weakens a harness and may cause failure during a fall. Question 3. What causes dropped object incidents? Answer: unsecured tools, poor housekeeping, improper storage, missing barriers. Common failures and lessons learned. Many fall incidents occur because times workers disconnect temporarily, times anchor incorrectly, times use incomplete scaffolds. Dropped object incidents frequently occur during simultaneous operations. On-site application. On major projects, HSE assistance commonly. Times inspect scaffolds. Times check harnesses. Times monitor exclusion zones. Times verify scaffold tags. Times conduct dropped object inspections. These are essential competencies in shutdown and construction environments. Section 5. Lifting operations and crane safety. Learning objective. Understand lifting operation planning, crane safety controls, and lifting team responsibilities. Concept explanation. Lifting operations involve moving loads using cranes or lifting devices. Lifting incidents can result in times crushing, times structural collapse, times drop loads, times fatalities. Every critical lift requires planning. Lifting plan essentials. A lifting plan includes times load weight, times crane capacity, times radius, times ground conditions, times lifting path, times exclusion zones, times communication methods, times environmental conditions. Roles and responsibilities. Lift supervisor controls the lifting activity. Crane operator operates equipment safely. Rigger attaches lifting gear. Banksman signalman directs movement using hand signals or radio. HSE officer monitors compliance and exclusion zones. SWL versus WLL. SWL, Safe working load. Traditional term for safe load capacity. WLL, working load limit. Modern industry term. Never exceed rated limits. Sling inspection. Inspect for times cuts, times broken wires, times deformation, times corrosion, times damaged hooks, times illegible tags. Defective lifting gear must be quarantined. Exclusion zones. No person should stand under suspended loads. Barricades and spotters prevent unauthorized entry. Load swing causes. Load swing due to times sudden crane movement, times wind, times improper rigging, times poor communication. Taglines help control loads. Communication signals. Hand signals must be times standardized, times visible, times understood by all parties. Only one designated signalman should direct the crane unless emergency stop is required. Practical activity. Pre-lift inspection. Inspect times crane setup, times outriggers, times slings, times shackles, times exclusion zones, times lift plan documentation. Ask, what could fail here? Quick quiz. Question 1. What does SWL mean? Answer, safe working load. Question 2. Why are exclusion zones required? Answer, to protect personnel from suspended load hazards. Question 3. What causes load swing? Answer, wind, sudden movement, poor rigging, poor communication. Common failures and lessons learned. Major lifting accidents often involve times overloaded cranes, times unstable ground, times poor rigging, times uncontrolled load movement. One recurring issue is unauthorized workers entering lifting zones. On-site application. Junior HSE personnel regularly. Times monitor lifting zones. Times inspect lifting gear. Times verify lifting permits. Times support critical lift reviews. Times observe crane operations during shutdowns and maintenance. You have now completed Module 6. Permit to work, lockout tagout, and high-risk operations. This module covered some of the most critical operational control systems used across high-risk industries worldwide, including times oil and gas facilities, times petrochemical plants, times shutdown and turnaround operations, times construction megaprojects, times fabrication yards, times power generation, times manufacturing environments, times and permit-controlled industrial workplaces. The systems discussed throughout this training are not administrative formalities. They are life-preserving controls designed to prevent catastrophic incidents. Industrial history repeatedly shows that major accidents rarely occur because hazards were unknown. Most major incidents occur because controls failed, were bypassed, or were not properly verified. A permit was approved without proper isolation. A permit was approved without proper isolation. A gas test was skipped. Stored energy was not released. A scaffold was modified without inspection. A worker entered confined space without atmospheric verification. A suspended load entered an uncontrolled area. These are not small procedural errors. In high-risk industries, they are fatal failure pathways. Professional HSE practice therefore requires more than basic awareness. It requires times technical competence, times operational discipline, times hazard recognition, times communication, times leadership, times verification, times and continuous control of work. A professional safety practitioner must understand not only what the procedure says, but why the control exists. A permit to work system is not simply paperwork. It is a formal authorization process designed to ensure that hazardous work is planned, isolated, communicated, monitored, and safely completed. LOTO is not simply placing a padlock on equipment. It is a controlled energy isolation process intended to prevent unexpected startup, stored energy release, electrocution, crushing, entanglement, and fatal injuries. Confined space entry is not simply entering a tank or vessel. It is a high-risk activity requiring atmospheric control, ventilation, rescue capability, communication systems, and strict permit compliance. Working at height is not simply wearing a harness. It requires proper planning, competent scaffolding, secure anchorage, fall prevention systems, inspection discipline, and dropped object control. Lifting operations are not simply moving loads. They involve engineered planning, equipment integrity, exclusion zone management, communication systems, and competent supervision. As future HSE professionals, supervisors, coordinators, and operational personnel, you must develop the habit of verification. Always verify. Times the permit, times the isolation, times the gas test, times the scaffold tag, times the lifting plan, times the communication process, times in the actual field conditions. Never assume conditions remain safe because they were safe earlier. Conditions change rapidly in industrial environments. This is especially true during times shutdown activities, times simultaneous operations, times maintenance work, times emergency repairs, times startup operations, times in confined work environments. At KHAB 17, HSE Global Safety Leader, we believe safety leadership begins with competence and professional responsibility. Final recap quiz. Question 1. What is the purpose of a permit to work system? Answer. To formally control hazardous work through authorization, hazard identification, and specified safety precaution. Question 2. Why is verification of zero energy essential in LOTO? Answer. Because equipment may still contain hazardous stored energy even after shutdown. Question 3. What gas testing sequence should be followed in confined space entry? Answer. Oxygen first, then flammable gases, then toxic gases. Question 4. What is the difference between fall prevention and fall arrest? Answer. Fall prevention stops exposure to fall hazards. Fall arrest stops the worker after a fall occurs. Question 5. Why are exclusion zones critical during lifting operations? Answer. To prevent personnel from being struck by suspended or falling loads. Final compliance disclaimer. This training is for educational purposes aligned with NEBOSH IGC IOSH Managing Safely ISO 45001 principles and industry best practice. Learners must always times follow site-specific procedures, times comply with local legislation, times obey company standards, times and work only under authorized supervision. Completion of this module does not authorize independent high-risk work. Authorization must come from competent site management and applicable permit systems. End of Module 6.